So 6.1, polar coordinates and equations. So this is where we're going to start learning how to graph a different way. Instead of using rectangular coordinates, x, y, where we would go right for a positive and left for a negative and up for a positive y and down for a negative y, we are going to now start graphing points on a plane by doing r is a radius length and theta is an angle of rotation, where we call the origin the pole of our polar graph and the x-axis, positive x-axis, is our polar axis. So if you want to fill in these words I intended for you to follow along with, are called the pole and the polar axis, which is easy, just written there on your picture and also in this paragraph. Okay, so even though it's in the order of r first and theta second, when I am actually graphing these, I usually do the angle first and then r. And a positive r moves forward along that angle terminal side, and a negative r would move backwards along the terminal side. So let's look at some examples. Yes. All right, so we have r first and then theta. However, I just got through saying that I prefer to do theta first and then r. So I'm going to go to the angle 5 pi 6. So here's my pole, here's my polar axis. I'll do those kind of in a lighter color. And then I'm going to rotate around to 5 pi 6, which is over here. Right here, 5 pi 6, right? I'm not drawing very straight lines, forgive me. And then now that I've found the correct angle, now I need to find the correct radius to put my points. So I've got these little grids here where you can count each one if you want as one length. So radius length 4, 1, 2, 3, 4. That would put the point in polar coordinates to be located right there. All right, example number 2, our radius is negative 3.5, angle pi fourths. So again, we're going to start at our pole, our polar axis, rotate around to pi fourths. That puts us at this line right here. Let me get a straight line drawer. I think that will help a little bit. So technically our pi fourths angle is right in here. However, it's a negative radius. So I'm going to go ahead and mark that entire line because of a negative radius, that instead of going forward 3.5, I'm actually going backwards along that line. So it really ends up being at the angle 5 pi fourths instead. 1, 2, 3.5. So there's our angle, or our point right there. Does that make sense? How we did a positive angle to pi fourths, but then a negative radius backwards. Negative radius. Perfect. Yep. You guys are good. Okay, let's look at number 3. So this time we have a negative angle. So we're going to go to negative 3 pi fourths, which would take us this direction. And then a positive 3.5. So 1, 2, 3.5. Well, that's really interesting. What did we end up with on this problem? We ended up with exactly the same point that was in example 2. Example 2 and example 3 are the exact same point written 2 different ways. So this one was written as a positive pi fourths and a negative 3.5. And this one was written as a negative 3 pi fourths and a positive 3.5. And Tyson pointed out that we could also do 5 pi fourths with a positive 3.5. And what else, Adrian? Are there any other options? It seems like there should be. Let's see, we've got We've got one where our radius is negative and our angle is positive. We've got one with a positive radius and a positive angle. What if we had a negative radius and a negative? What if we wanted our radius to be negative 3.5, but we also wanted our angle to be negative? What would that be? I know, I'm struggling too. I think it would be negative 7 pi fourths because it would be going all the way around to negative 7 pi fourths, which is positive pi fourths, and then going backwards. So, interestingly enough, there's 4 different ways to write that point coordinate, and that's just in the interval from negative 2 pi to positive 2 pi. That means there's actually infinitely many ways to write the coordinates for these points. Well, part of what we're going to be doing on section 6.2 though is we will actually be plugging points into formulas and finding the results and then graphing them. So that's why we need to understand how to graph them no matter what, because sometimes we'll be plugging in negative values or we'll plug in positive values and get out negative values. I mean, there's all sorts of things that can happen. So that's why we need to know how to graph them. So anyway,